Hello, welcome to lesson 2, setup of a simple electromagnetic simulation. So in this lesson we're going to look at the different stages that you need to go through to set up an electromagnetic simulation and the processes to follow. So I'm going to take you through the process of setting up this simulation, show you what the simulation tool does to solve the problem, and then actually in the next lesson we're going to look at the results from this. I'm going to do this demonstration in HFSS. As I said, this is a little bit more standard in industry than CST, and particularly if you're an antenna engineer, you'll be using HFSS. If you want a bit more of a detailed look at this stuff, you can have a look at my thesis, which goes into a lot more detail. So the first thing you need to do is draw the geometry. HFSS is natively an entire block of metal, so essentially you chisel the geometry out of it. This is the same reflector that we saw in the measurement setup a few lessons ago. So the reflector, the plastic reflector, is the peach coloured block. The pink strips on top of that are your metal grid lines. And they're at a certain pitch, which is your GLP, your grid line pitch. They have a certain width, your GLW, your grid line width. They have a certain depth, which is your grid line depth. The entire structure is actually surrounded by an airbox. So I said HFSS is natively metal, which is brilliant unless you're trying to transmit a signal. So you need to chisel an airbox out of that. And the airbox is dependent on the wavelength that you're using. It has to be at least the wavelength divided by 2 in height above and below the item that you're trying to simulate. So you set up your ports where you want your radiation to go from and to go to. Very similar ideas when we were setting up on our vector network analyzer. You transmit from one port and receive on the other. You transmit from the top port and you receive on the bottom port in this instance. So the EM radiation is coming down through the plane of the simulation. You can set up a lot of different types of ports. And actually on this one there is also Flow-K port on each of the 4 sides, which makes it infinitely large. But you don't have to do that. A simple simulation can be just done as a unit cell. Because we're testing a reflector and we want to look at the different polarizations, this is also set up so that you can have different polarizations of radiation coming through. So you can have your E vector in one direction, you can have it at 90 degrees to it. So you're going to get 2 results, which is going to match the bench measurements that I showed you earlier. So you draw your geometry, you hit mesh, and HFSS meshes the geometry into regions. Unfortunately, I haven't got a picture of the actual reflector grid lines, but this is a representation of what you'll see. And it's at each of these boundaries of each of these little tetrahedra that the geometry is broken up into, that HFSS solves Maxwell's equations. What you're going to see is there's a difference. You get a differential meshing. In the kind of sparser areas where there's nothing of interest, the mesh is quite large. Whereas the mesh adapts if you've got intricate areas and it meshes into smaller tetrahedra, so you get a more accurate result. The good thing about HFSS is it can actually simulate inside the thickness of the grid line, which was actually really important for getting the reflector to work correctly. So, conclusions for lesson 2. We've looked at the different stages required to set up an electromagnetic simulation. So you've got to draw your geometry, draw your airbox around it, set up your ports, do your meshing. And we're going to go on next to have a look at the type of results that can be extracted from our simulations.